Remember our farmer from the intro video? Well, now we have a name for him. His name is Jim Bob Joe. Okay, great name. Might name my first kid after that. Maybe not. But anyway, Jim Bob Joe is farmer. Okay, and so we can use methods from math analysis to do this, but we learned calculus, and we want to use calculus methods. So presumably in all these exercises, if you can use a simpler approach, I want you to use calculus. Okay, so let's kind of go through that process. The idea is that he has a rectangular area, right? And he wants to divide it into 5 pens. So 1, 2, 3, 4, and 5. Okay, and in total, the fencing, so if this is, this is X, I'm going to do X, 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 and this is X, 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 and this is Y, 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 Y. Whew. Okay. All those pieces, so 10x plus 6y, have to add up to 950. Okay? And this, my friends, that's your constraint. Okay, I have to have that requirement met. But what I'm really interested in is the largest possible area for each of the 4 pens. Oh, did I say 4 pens? Oh, dang. Okay, so I need to modify this. I only want 1, 2, 3, 4. Okay, so I need to get rid of this and that. Okay, so let's revise this. So it's 8x plus 5y. Okay. See, that's why it's important to read the problem, kids. Huh? Yeah, yeah, yeah. Okay, but anyway, we want to find area. Okay, and the area, the let's see, largest possible total area for the 4 pens. So the total area is going to be here 4x one side times the length. Oops, that should be an x, not a y. X times y. Okay. So now I need to manipulate my constraint equation and then substitute that into my area equation. So I'm just going to give this a name as A. Y is going to be, 950 over 5, which is 190, and then minus 8/5 x. Okay, so I'm going to use that in my equation and just say this is 190 minus 8/5 x. Okay, so 4 times 190, let's see, that's 760 x minus 32/5 x. Okay, so now I have an area function that is a function of x. Okay, now I'm going to pause a moment here and ask myself, am I on a closed interval? Okay, well, again, if I think about the range of x, or the domain for x, I should say, let's see, the minimal that x can be, well, can it be 0? Well, not really, right? Because otherwise I don't have any pens. And the maximal is going to be, well, let's see, it would have to be kind of an upper limit would be 950, 950 over 8, right? Because that would mean that y would be 0 and we would just have these 4 things. So it has to be somewhere between those two values. Okay, certainly this is not a closed interval because again you can't have the endpoints. Okay, so once again I'm kind of stuck. I need to just do the normal method of find the critical numbers and test those. If I had it as a closed interval, I'd use a closed interval method. Nevertheless, a prime is going to be 760, and this was squared. I forgot the squared. 760 minus 64 over 5 times x. Set that equal to 0, and we can solve. 59.375, and then when you go through and find it, your y value is going to be 95. Okay, but now, like I said, this is this is not enough. You need to verify that this is indeed a maximum. So in this case, I would do the second derivative test once again, and you just get minus 64 over 5, which is less than 0, which automatically means that you have a local max at x is equal to 59.375 by the second derivative test. Okay, and then consequently, if you're looking for the largest possible total area, you would have to, go back and say area is 4 times x times y, and if you do this, you end up getting 22,562.5 square feet. Okay, and I would say you just need to write this in sentence form, which I'm not going to do for time purposes. Okay, but again, if you are presented with a context, you should respond in context. Okay, but just to recap, I drew a picture, identified the constraint from the 950, identified the area or the function that I actually wanted to optimize, which was area, used my constraint in the area function, and then went through and classified any, or I guess found any extrema, absolute or local. I only had local because I was on an open interval, and I found the critical numbers and classified them as a maximum according to the second derivative test.